Okay, hi everyone, and this is going to be part two of lesson four. So we're going to move on to the next part. I just have to cut the lessons into pieces because if I record for too long, then it won't let me upload it. So that's why some lessons might be one or two parts. So how can we solve a quadratic function graphically? So a quadratic function is written in the form ax squared plus bx plus c. So the part that makes it a quadratic equation as opposed to linear is the fact that one of the x has an exponent of 2. Okay? And that's what differentiates it from other functions that we've been seeing. And the graph of a quadratic function is called a parabola. So um, on Google Classroom, I posted the link for a tutorial for Desmos. So if you don't have a graphing calculator, you can go into Desmos like I'm going to do right now. And I want you to put in this following function, x squared plus 5x plus 6. And I'm going to go through labeling these following three things of the graph. First, we have the vertex, which is the turning point, which is the maximum or minimum point, which you might be familiar with. We talked about this earlier the year. The solutions of the graph, which are one of the most important pieces here, and the line of symmetry. So right now, I'm going to go onto Desmos, and I already graphed it, and this is what it looks like. Okay, so here I put it on the side. If you're using your phone, it should pretty much look the same. Or here, make sure you put in the exponent of 2. Okay, so I have x squared plus 5x plus 6. So this is what the graph looks like. So I'm going to go through labeling the different pieces. So right here, okay, is what's called our vertex point. Okay, so our vertex is our minimum or maximum value. Okay. Now, that's one piece here. The most important is our solutions. So the solution of a quadratic or a parabola is where the graph hits the x-axis. So if you see right here, this point right here and this point right here, what I put in red, these are what we call our solutions. Okay? So these are our solutions. So these have a few different names. They're called solutions, roots, zeros, or x-intercepts. Okay, so they could have 4 names that you can see on a test or on the reasons exam coming up soon. Okay, so here, the 2 zeros, the physical points are -3, 0, and -2, 0. So now, maybe you could think, wow, why are they called 0? Is because they're on the x-axis, right? This is our y. And both of the y values are 0. So the solutions, just as a side note, are where the y values are 0. That's also why they're called zeros, okay? So they're the x values when the y value is 0. So -2 and -3 are the solutions of this parabola. All right, and the last thing here is the line of symmetry. So the line of symmetry is where the it's the vertical line that breaks the parabola in half evenly. So here, the line of symmetry goes right through that vertex point. So the line of symmetry of any parabola goes through the vertex point. So it's the vertical line here, okay? And it is the vertical line that breaks this parabola in half. So here, this line would be x equals 2. It's right in between -2 and 3, -2.5. So that would be the equation of that line. So this would be your line of symmetry. Okay. So really the most important piece here are our solutions. So these 2 points, -3 and -2, are where the parabola hits the x-axis. So that's where you would locate your solutions and or roots, zeros, x-intercepts, any of these 4 words, 4 phrases you need to know. All right. And that concludes this part, and I'm going to go to one more part doing one more modeled example for you guys.